Hello, today is May 21st, 2024. Today we're going to talk about algebra. In particularly, we're going to talk about the factoring. Before talking about the factoring, there's a couple things I want to share with the team here. So first is the naming the file. So right now, in order to better for sorting, instead of put a month, date, and a year, I'm going to start with the year first, and then the month, and then the date. And then our dash, for instance, 3, because this is my third video for algebra. So that way, it's easier for you guys doing the sorting later on as more and more video is being published. Because if we name in the file that way, we will never repeat ourselves, because the year keeps increasing, right? Okay, anyway, let's okay, another thing I want to tell you is before we talking about the factoring, I just want to go over a little bit what I tried to explain, but I didn't cover it last time when we're talking about exponent. The one I want to share is, what if the exponent actually is a negative? You have a negative power. For instance, 2 to the power of negative 1. What is that? That is going to be a fraction. It's going to be 1 over another number. What number is it? It's exactly the same number, except instead of negative power, it becomes positive 1. So it's going to be 2 to the 1. So that would be 1 over 2. Okay, let's try another one. What about 2 to the power of negative 2? Again, it's a fraction. It's 1 over the whole number right here, except the negative power need to change to positive power. So it's 2 over power of 2. It's going to be 1 over 4. Okay? So now let's do a little bit more complicated example. For instance, if we have 3 to the negative 2, y to the power of 0 over x to the power of negative 3. How do we calculate that? Again, it's divided by divider and conquer, right? We look at this part first. That would be equal to 1 over 3 to the positive 2, right? And then the second one is y to the power of the 0. Any number to the power of 0 that equal to 1. Okay, you have to remember that. So that's 1. And then the x to the negative power of 3, it will be 1 over x to the positive power of 3. Now we know this times 1 is going to be equal to themselves. So when we divide it by another fraction, how do we do that? It's pretty simple. It is the original number right here divided by a fraction. It is equivalent to multiply the reciprocal of this fraction, which is x to the power of 3 to the top, y to the bottom. So that indeed will equal to x cubed, and then 3 to the power of the 2, which is 9. So that is your solution for this problem. Okay, so now let's working on today's subject. Before doing the factoring of the polynomial, I just want to do a quick review of addition of the polynomial. We discovered this before, but I just want to remind you, just in case you forgot. For instance, we have one polynomial It's like that. And then plus 1. And then we have second polynomial plus 2. If we try to add those two polynomials together, how do we do that? Again, so first we write down the first polynomial. The second thing, we have to write down this second polynomial underneath. Notice there's a lot of different ways we can write it. We can write down everything right here, or we kind of like write it here, here, and then all the way to the right. What would be the correct way? We have to look at the variable and make sure whatever the power it has match up with the previous one. So for instance, constants, you would be right underneath the constant. So it's plus 2. And then this is to the x to the power of 1. So the negative 4x is also to the x to the power of the 1. Okay? So that would be 25x. If we have an x square, we need to put it right here. If we have a cube or x to the power of the 4th, we have to write down on this side, so on and so forth. And then we put a plus, this plus corresponding to this plus right here. And then we will put a parenthesis, which separates the operator with the rest of the polynomial. And then 1 plus 2 is equal to 3. That's positive 3. Negative 4 plus positive 25. So it's positive 21x. And then this one we just copied. Okay, so now we did enough review. Now let's working on indeed the subject we want to cover today. For instance, if I give you a polynomial like this, I want you to factoring the given polynomial. How do we do that? Okay, so first, the coefficient of the x squared term is 1, even though we don't write it. So that we can decompose it. When I say decomposed, basically I want to find a two factor such that the product of those two factors equal to 1 right here. So the only thing we can decompose is 1 plus 1. 1 times 1. Indeed, you can view this as x right here, but the thing is, we often omit this x to simplify. Now we look at the constant term. Again, we need to decompose them, right? So there's a lot of ways to decompose them. We can, let's say, we can decompose that 1 times 6, or we can decompose them as 1, put in the top, 6 at the bottom. Now we do the cross product. And then we see after the cross product, and then we add those two results, whether we can get this term right here or not. Let's check. 1 times 1 equal to 1. 1 times 6 equal to 6. 1 plus 6 equal to 7. So the 7 won't match up 5 right here. So this is no good. The first thing no good. Let's look at this. 1 times 6 is going to be 6. 1 times 1 is going to be 1. 6 plus 1 still 7. 7 is not equal to this 5. No good. However, if we decompose 6 as 2, 3, and then the first one, again, we cannot change it after we decomposed it, is 1, 1. Now 1 times 3 is 3. 1 times 1 is, 1 times 2 is 2. And then 3 plus 2 equal to 5. That is exactly equal to the component in the middle. If that is the case, then all we need to do is use this term times this term. Notice we have x right here, x right here. We just omit it for simplification. indeed the first term will be 1 times x plus 2 times 1 plus x plus 3. So let me rewrite it. It's going to be x plus 2, x plus 3. So we already factoring this. So the result is going to be x squared plus 5x plus 6 equal to x plus 2, x plus 3. So what exactly factor means? Factor means we change the given polynomial to the product of one term or with another term. That's called a factoring. Okay, so with that being said, let's working for another factoring. So what if I give you the following? X cubed minus 4x squared plus 4x. How do you factor this? Notice for this polynomial right here, we have a constant term called x. So what we need is we first factor our x. Factor our x means you use every term divided by this factor. So x cubed divided by x, what you left is x squared. Negative 4x squared divided by x would be negative 4x. The last term 4x divided by x is 4. You might be wondering why we divide by x. Look at it. If we use this to multiply each of the term right here, we will get the originally polynomial. So that's why we need divided by the common term first. Now what we need to do is we look at the inside, this part. That's indeed is the brand new polynomial, right? It's x squared minus 4x plus 4. Again, for 1, that's the only choice. We can decompose the component. For this one, there's a lot of ways, like 4, 1, 1, 4, or positive 2, positive 2. Any of those, after you use the cross product, you can't get the middle coefficient. The only way you can get is if I decompose the last constant 4 as negative 2 times negative 2. Because negative give you a positive, right? However, if we do in the cross product, 1 times negative 2 is negative 2. 1 times negative 2 is another negative 2. Those negative 2 formed together is going to be negative 4, which is exactly the coefficient right here. If that is the case, we got a product of the top term times bottom term. So that would be equal to x subtract 2 times x subtract 2. In other words, that would be x subtract 2 to the power of the 2. So the original polynomial x cubed subtract 4x squared plus 4x equal to x subtract 2 to the cube. You might wondering, why we need doing the factoring. I'm telling you, the factoring, one of the benefits of factoring is it will help us to solve the equation. For instance, if I give you, let's say, if I give you something like the following. If I give you, if the given polynomial is x cubed plus 5x squared plus 6x. this is a given polynomial, right? If I put the polynomial equal to 0, then suddenly the polynomial become an equation. The difference between expression to equation or polynomial to equation, it is this guy, the equal sign, right here. Once you have an equal sign, this goes in called equation. If I ask you solve for the given equation, what I really want you to, I want you to find the value of x such that I plug in the value right here, the whole thing equal to 0. Okay, so how do I do that? Again, we have to use the factoring. If we just look at the polynomial right here, do we have a common term? Yes. What is that? X. That's correct. We put x aside. So the first term divided by x, we got x squared. Next term divided by x, we got a 5x. The last term divided by x, we just have 6. And then that thing is equal to 0. Because we haven't doing anything yet, right? We just factor out the x. Now look at this guy right here. Again, the first term is going to be decomposed as 1, 1. The last term, again, is going to be 2, 3. At the very beginning, you might not get it as quick as I did, but as you working on tons of the different questions, you will get ideas. So if 1 times 3, you got a 3. If 1 times 2, you got a 2. As those 2 equal to 5, that's exactly the coefficient of the x term. So we can rewrite this as the following. Whatever the first term x, we just copy it down. The second term will be this guy right here, which is x plus 2. And then again, this guy right here is going to be x plus 3. Again, this imply x right here. We just omit it to simplify. We know the whole thing equal to 0. Now we got 3 terms, right? 1, 2, 3. In other words, if a times b times c equal to 0, then either a equal to 0 or b equal to 0 or c equal to 0. Do you agree? Because 0 times everything is still equal to 0. So in that case, if a is 0, b and c is not 0, the whole thing is still going to be 0. Similarly, if b is 0, a and c, whether they are 0 or not, the whole product is 0. Same case for c. So in this case, look at the originally equation. So it's either going to be a equal to 0 or the second term, which is x plus 2 equal to 0, or x plus 3 equal to 0. And then for the first one, it's just x equal to 0. For the second one, if we subtract 2 on both sides, we will have x equal to negative 2. Or the last one, if we subtract 3 on both sides, we will get x equal to negative 3. See how powerful the factor it is, right? So if we are very good at factoring, if the given polynomial indeed can be rewrite as the factors, then you can solve for the equations. So that's pretty much it I want to share with you guys today. Feel free to subscribe, to leave any questions in the commenting area, and then we're going to talk more the next time. Thank you. Bye-bye.